President Appeloig, Vice Presidents Rosen, CD, Professor Skorecki, Dr. Ron Evans, Harvey family, Technion administrators, and distinguished faculty, students, friends, relatives, and guests, thank you. My family has had a great time in the last few days, touring Israel, visiting the Technion, and spending time with Ron and Ellen Evans, who are wonderful people. To receive the coveted Harvey Prize is quite an honor. I sincerely appreciate it, and I am happy to accept it. I would not be here today if it were not for the generosity and encouragement of many people, and I am going to name names. First, I thank my parents, who before I was even a teenager gave me an electronics kit. From this, my interest in electronics grew, and I became an amateur or ham radio operator, and I was completely engrossed with this hobby. I loved everything about radio waves. I also want to thank my grandmother, Miriam, of blessed memory, who gave me a small telescope when I was in the 9th grade. I took it into my backyard, and I looked up at the night sky, and it was beautiful and amazing. I read books about astronomy that said that radio waves come to us from beyond the Earth, and my two hobbies were merged, radio waves and astronomy. I read that radio waves from the Big Bang had been detected by scientists only a few years earlier in 1965. Wow. By the end of the 9th grade, I knew my career. I was going to study radio waves from space. My parents took me to the National Radio Astronomy Observatory in nearby West Virginia. What kind of lucky people get to use big radio telescopes like these, I wondered. Now, many people advised me that listening to radio waves from space sounds like it might make a nice hobby, but that I shouldn't expect anyone to actually pay me for it. You'll need a paying job, kid, they would say. I am also grateful to Professor Bill Erickson, then at the University of Maryland, who generously took me under his wing and taught me radio astronomy, and I wrote an undergraduate thesis on my own radio observations of the remnant of an exploded star. My grandmother Miriam was friend with the mother of a now famous astronomer, Vera Rubin. They knew each other through their Hadassah chapter. Small world. Vera Rubin is an exceptional astronomer and role model for women in science everywhere. I want to thank Vera Rubin, who put me in touch with Kent Ford at the Carnegie Institution of Washington in Washington, D.C. He hired me to work with him during the summers on astronomical instrumentation, and I am quite certain that I got much more out of the job than he did. While at Carnegie, I was introduced to Professor Bernard F. Burke, Bernie Burke of MIT. He invited me to come do my graduate work and to join his research group at MIT. I waited almost an entire second before saying yes. After 6 years at MIT, I spent more time in observatories than I spent at my apartment in Boston, including the observatory that I had visited with my parents years earlier. I used the telescopes there more than anyone else in the world. You see, Bernie had a motto: you can't discover anything about astrophysics unless you're looking at the sky. So I spent a lot of time doing that, and that lesson has stuck with me ever since. I want to thank MIT Professor Ray Weiss. He gave a talk about a NASA satellite called the Cosmic Background Explorer, COBE, that was being built to observe the radio waves from the Big Bang. It was the most fascinating thing I could imagine, and I asked if there was any opportunities for me. He told me that the head of one of the instrument teams was in Berkeley, California, and that the team desperately needed somebody at the Goddard Space Flight Center in Maryland to help build the instrument on a day-to-day basis. Perfect. I thank Mike Hauser for hiring me and the Kobe science team for voting me in as a member. I became a NASA employee. I got married to my MIT sweetheart, Renee, and dragged her off to Maryland. I want to thank Renee for making this the first of many sacrifices for me. I now actually had a real paying job for doing exactly what I wanted to do. Soon thereafter, I became one of the leaders of the Kobe space mission. Kobe launched in 1989 and made many major discoveries, two of which were just recently recognized by the Nobel Prize in Physics. Kobe observed those same radio waves from the Big Bang that I had read about as a kid. Kobe found the radiation to have the properties predicted by the Big Bang theory, and it found tiny differences in the temperature of the radiation from spot to spot on the sky. Astrophysicists had long felt that these ripples had to be there, and Kobe ended a 27-year search for them. In the midst of the Kobe work, my son Andrew was born. He grew up together with my work on Kobe. I still remember an overly vigilant NASA quality assurance manager kicking me out of the room for carrying my baby Andrew into a NASA test facility with me. Andrew is now an economics major at Vassar College, headed towards law school. As Kobe was winding down, I led a proposal effort to follow up on Kobe results by building a new NASA satellite. The proposal was accepted in 1996, and the MAP satellite was launched in 2001. David Wilkinson, a founding member of both the Kobe and MAP teams and a Princeton faculty member who trained an entire generation of students in this field, passed away shortly after MAP launched, and I'm glad that he lived long enough to see it. I am grateful that NASA followed the recommendation of my team to rename the satellite in his honor as the Wilkinson Microwave Anisotropy Probe, WMAP. I am grateful to Dave for being so supportive of me through 2 space missions and for his confidence in my ability to lead the WMAP mission. And I especially want to thank the WMAP team. It has been a wonderful pleasure to work with these fine scientists. It is easy for me to stand here, but doing so is the result of a lot of hard work by a lot of people. And I freely and warmly acknowledge their essential contributions to the success of WMAP. They could have done it without me. I could not have done it without them. My second son, Ethan, was born at the start of WMAP, and so it is fitting that he is here today, illegally absent from school, on his first trip to Israel a week following his bar mitzvah. By 2003, the WMAP team issued scientific results in what are now the most cited papers in all of science. WMAP, 1.5 million kilometers from Earth, continues to take high-quality scientific data as I speak. When I was young, I looked up at a peaceful night sky. You know the phrase, "I'm as constant as the northern star," says Shakespeare's Julius Caesar. But the northern star is not constant. Nothing in the universe is constant. We live in a dynamic and evolving universe. We have known for 80 years that our universe is expanding or stretching. The Big Bang Theory has been around for 60 years, including a prediction that the sky should be filled with a microwave afterglow, a cosmic microwave background radiation. The Big Bang Theory competed with the steady state theory for years, until that discovery in 1965 that I read about as a kid, that the sky is filled with radio waves from beyond the Earth. The cosmic microwave background radiation is just as the Big Bang Theory predicted. This microwave afterglow is an invaluable fossil, billions of years old. It is the oldest light in the universe. I have spent my career studying it, forcing it to give up its secrets. With the WMAP satellite, the afterglow gave up many secrets. For example, we now know that the universe is 13.7 billion years old. The atoms of the periodic table of the elements that we learned about in chemistry class make up less than 5% of the universe. Almost 25% of the universe is made up of a very different kind of matter. We call it cold, dark matter. But compelling questions remain. We see the gravitational effects of cold, dark matter, but this unknown form of matter gives off absolutely no light at all. I would really like to know what it is. I think that many people would like to know what the dominant form of matter in the universe is. And then there's the dark energy question. There's a lot of matter in the universe, and one would expect that after eons and eons, no matter what initially sent these bits of matter moving away from each other, their expansion would eventually slow, and perhaps the bits of matter would even start falling back together. This is the large-scale analog of throwing a ball up into the air. After a while, gravity pulls it back to Earth. But the expansion of the universe isn't slowing down. The matter may not eventually collapse back together again. An amazing discovery was made in 1998 by Adam Rees, whose office is next door to me at the Johns Hopkins University. The ball is not slowing down, it is speeding up. That is, the rate at which the universe is expanding is actually accelerating. I want to know what's going on. The nature of the dark energy that is driving the accelerated expansion of the universe controls the ultimate destiny of the universe. I would like to know what this mysterious energy is. I suspect that many people would like to know about the ultimate fate of the universe. And perhaps the most compelling question as yet unanswered: how did the universe begin? This is the stuff of myths and legends, but I ask the question as a scientist. The answer is not the Big Bang Theory. Despite the popular misconception, the Big Bang Theory says nothing at all about how the universe began. Many mysteries remain, and unraveling these mysteries is exciting and it's fun. Doing it with wonderful colleagues, supportive friends and family make it all the more sweet. And the Harvey Prize is a frosting on the cake. Thank you so very much for this great honor. Toda Rabba.